Every packet you've ever sent, email, video, or buying 0DTE puts on Robinhood passed through a circuit that most engineers never even think about. Yet, this circuitry powers everything and custom implementation are used everywhere, ranging from aerospace to finance applications. You don't need to be an engineer to follow this. By the end of this video, Ethernet will have zero secrets left for you. Let's dive in. So what you are seeing on your screen right now is an application running on my custom CPU, and it's processing live data coming over Ethernet. You might have seen this before. A while back, I built a CPU from scratch and I ran Doom on it. It had a pretty awful frame rate. It was completely pointless, but oh boy, it was worth it. But I wanted to push a little further. What would happen when this thing talks to the outside world? The idea was simple. Generate a waveform on my main PC, sample the said waveform point by point, send each and every point via Ethernet to the Holy Core, which is the name of my CPU, and then the Holy Core should send the exact same samples back. But of course, nothing about this is simple. The Ethernet cable sends electrical signals to your PCB, but these electrical signals mean absolutely nothing. So on most PCBs, after the Ethernet port, you will see what we call a PHY chip, and its job is to interpret the electrical signals as zeros and ones. These zeros and ones are then passed to the rest of the systems, to the other chips, via what we call MMI. And our job when creating a MAC, which is the name of the hardware that handles the understanding of Ethernet, is to parse these signals in order to get correct Ethernet frames. In my case, everything will run on an FPGA, but it could be anything. So because I run everything on FPGA, I have to make my own MAC. And so after getting a small hardware demonstrator going, I, with the help of absolutely nobody, built a little interface to send and receive Ethernet packages, which contains the waveform samples. So let's test it out. Damn! On the left are the samples going to the CPU, and on the right are the ones coming from the CPU. And there are some things that are obviously wrong. Ethernet frames are simple. We can store many bytes in the frame payload, up to 1500. And the program the AI wrote did not quite understand my firmware was expecting a single sample per frame, because it's a dumb waste of space when you think about it. It instead packed tons of samples in a single frame. The AI also sent my samples in the form of a floating point number, which my CPU obviously don't support. So I fixed both the interface and the firmware, and we finally got something working. So you can see there is a little stutter from now and then. I do know why, but I decided to ship it anyway. Engineers will understand. It was definitely very satisfying to see the whole system come together, and knowing that my own CPU was mirroring live Ethernet data. We can also take a moment to play around with the way the CPU returns the samples and how they are displayed in the TUI. Mirroring a signal is cool, but I think we can do better. What if the CPU actually processed the incoming data? I want to do an FFT, or a fast Fourier transform, which sounds intimidating, but the idea is very simple. Instead of looking at the signal over time, you look at which frequencies are hiding inside it. But we encounter a problem. Because of the way FFTs are computed, I need 256 samples. But right now, we only transmit one single sample per frame. To make the software side easier, I want to put all the 256 samples in a single Ethernet frame. Theoretically, they should fit, because 256 samples of 32 bits equals to 1024 bytes, which is well under our 1500 bytes budget. So no problem, right? We are cool and everything is okay. Wrong. The hardware responsible of parsing incoming Ethernet frames, which are referred to as the MAC, works in a very specific way. it will receive Ethernet signals, it will parse it, and it will start streaming live data to the rest of the system. And again, this data burst is expected to be 1024 bytes wide. But this data stream does not go towards the CPU, as CPUs cannot consume live streams of bytes for a plethora of reasons. Instead, the data stream is redirected to the RAM using DMA, from which the CPU can gather data later. But the DMA core was not designed for Ethernet frames specifically. In fact, internal resources usage in the DMA core only allow 64-byte bursts. Can you see the problem arise? Before the stream ends, the DMA core will take some short breaks to transmit its buffered data to the RAM. But in the meantime, our 1024 bytes frame is still going very strong, and it's not expecting any breaks. To fix this issue, we can add a FIFO, or first in, first out queue, that will serve as a buffer. And once the frame is complete, this buffer will handle the DMA consumption flow easily, even if it takes some breaks from time to time. The problem is the same the other way around when you want to send data, as my Mac is simple and does not handle the DMA breaks natively. So again, we add a FIFO and some workarounds to handle this problem. Okay, now guess what? We just have to write the firmware to apply the FFT over these 256 samples. Using only my very own knowledge, once again, I wrote a firmware that runs the FFT and returns the result of the analysis over Ethernet. And now, I guess it's time to test it out. And it worked better than I expected. You can see the FFT does really pick up all of the signal frequencies. And once again, we can play around in the TUI to display this FFT over time, you know, just like in the submarines. But okay, let's be real, we didn't really revolutionize anything here. But this exact thing, custom hardware processing live network data in real time, is what aerospace and trading businesses can pay lots of money for, and I built mine on an FPGA around my shitty CPU, which I think is kind of funny.
You serious?
So naturally, I had one last question. What happens when I feed this live market data and try to trade stuff? Well, that's for the next video. If you're wondering how this CPU even exists, I've got videos on that. Go check them out. And in the meantime, do not hesitate to like and subscribe because it really helps the channel more than you think. And I'll see you in the next one.